Okay, good afternoon. So let us continue the lesson. So now I go back to chapter 1. I also call it analytic geometry because I would say that this is the continuation of what we started with points. In chapter 1, so from the beginning of the book, we want to talk about another part of analytic geometry, which is related to the straight lines. Yes, it is very natural because we started about thinking about a point from analytic point of view, and then we want to learn that for straight lines. Of course, you should expect that it could be a little bit harder because if I ask you how many points are there on a straight line, you know that there are infinitely many. So somehow I need to find a way to present all of these points with one equation or one relation, you know, because of course, let me be more specific. So if I give you this coordinate system, x, y, and then I draw a straight line here. Let me change the color. So I have this straight line here. If I want to present this blue line in this coordinate system analytically, one crude way is probably to introduce the coordinates of all the points. Yes, even though in principle it might look possible, but it is not practical because there are infinitely many points. And I don't know how should I list the coordinates of all those points. Yes, if I want to give you an equation, if I want to present a line for you, if I want to present a point for you, I don't have any troubles. Yes, I give you two numbers and you immediately locate that point for me. Yes, but if I want you to understand about which line I am talking about, because you know that in plane I have infinitely many lines. If I want to tell you which line I am talking about, so I need to find a way to address exactly that line that you can find it. Yes. If I'm talking about this point, I can immediately address this point for you. For example, I can tell you, assume that this is 1.5. And then I can assume that this is 5. Then I would say that the point that I have in mind is point that I call it A, whose coordinates are 1.1, 1.5, and 5. Then you can immediately find a point for yourself. Yes? So it means that if I give you two numbers, that is enough for you to locate the point. But assume that I ask you to find and locate this line somehow, I need to understand how can I do that. That is the idea. I want you to think about it yourself, try to discover it again together, because otherwise this is not very helpful. So I want you to understand that what is my problem. So if I have on the board, so consider that these points, so these lines all are lying on this board. I can also move them around. These are different lines. I have infinitely many lines. I want to tell you in a way that you can pick up exactly one that I have in mind. So this I want you to ask you, how do you think I can address this? Which pieces of information do you ask me to find that line? Let me repeat the question. If I ask you, I want you to find a point for me, then you ask two questions. You ask what is the x coordinate of the point, and you ask what is the y coordinate of the point. As soon as I give you these two numbers, then you say that's okay, I will go and find the point for you. Is that understandable? Now we want to do the same thing with lines. How many lines I can imagine on the whiteboard? Infinitely many. So you are open, ask me questions. You can ask two questions or any number of questions from me so that you can go and find the line. Which line I mean. What questions are suitable to ask? Yes?
For 2 points on the line.
Yes, that is one possibility, yes. You ask me for 2 points on the line. If I give you these 2 points, then you say that I am done. Because I put my ruler next to them and draw the line that is your line. So if I give you 2 points. So 2 points is good. And that is enough. I don't need more. Yes? But why I don't need more? That is important. If I ask you to draw a circle, how many circles are in the plane? Again, infinitely many. If I give you 2 points of the circle, would that be enough to address exactly one single circle? No. Yes, because if I ask you how many circles passes through this, infinitely many. So 2 points is enough for the line, as you intuitively understand, but it is not enough for the circle, because I can consider a bigger circle. Yes, I can even consider, I don't know, bigger circle. All these circles are passing through those points. So it is not enough. If I give you 2 points of a circle, it is not enough to specify exactly the circle. Yes? But for the line, it is enough. And the reason is that this is the property of the straight line and one of the axioms of geometry, that for specifying a line, I need only 2 points on the line. Yes? Is that understandable? This is exactly one way. But I will not start from the 2-point strategy. Can you tell me another strategy to specify one single line? Is 1 point enough, by the way, or not? Is 1 point of the line is enough or not? No, because if I give you 1 point, you don't know, am I talking about this line? You don't know, am I talking about this line? Or I'm talking about this line? There are infinitely many points, infinitely many lines, again, possible. Yes?
At what rate of x and y is it like? How much x and y is it decreasing in
Can you? Yeah, that's correct. But can you make it simpler?
I
Yes.
don't know how you phrase it.
But that. Yeah, so let me see, Simon. What do you have to say?
What is the slope and what is the y value when x is 0?
Okay, I want to get to that point. What is the meaning of a slope? Might be you have studied some of these in the Grund school, but assume that you really don't know anything about a slope. Okay, so what we know in geometry. So okay, let me hear from Tim as well. Do you want to say the same thing? Okay, so you are right. So if I give you 1 point and I give you the slope, what is the meaning of a slope? A slope is somehow related to the angle. Yes, inclination angle. Yes. Okay, so that's exactly true. So it means that one way to do it is this. If I give you this point, it is not enough because there are infinitely many lines passing through this point. But if I also give you that the line is not only passing through this point that I call it A, but it makes an angle, for example, 60 degrees with the x-axis. Yes? So then it means that I cannot draw this line. This is not possible because this, for example, is bigger than 60. Okay, I cannot make it so narrow, yes, because then this angle would be less than 60. So it means that hopefully you understand, if I give you 1 point and I give you the angle that my line makes with the x direction, then still I can find my line. Is that understandable? I can say that a line, I can say the line, yes, the line that passes through A and makes an angle, for example, 60 degrees with the x-axis. So then it means what I have to do, I have to measure a 60-degree angle somewhere, anywhere that I like to. Then I take my ruler and go to this point and draw a line parallel to this one. And that again makes 60 degrees angle here, and that would be my line. So what you said is that I need 2 points, that is correct. One thing is that I have 1 point, but instead of having the second point, I have an angle. Okay, I want to start with this strategy first, yes?
If you use an arrow, is it always to the right?
Yes, so that you can have the convention on that. But the convention mathematicians use is the angle between the line and the positive x direction. So it means that, I will talk about that. If you have something like that, again, mathematicians talk about this angle. So the angle, by convention, the angle that the line makes with the positive x direction is important for us. Of course, you can have the convention and say the smaller angle. That's also possible. But this one that we make with the positive x direction has a particular name, and that is called the slope. That is convention, but it doesn't matter how you measure the slope, with the smaller angle or with this bigger angle. So this, my idea is that you understand that if I want to specify one single line among all lines in the plane, at least you see that we have two strategies. One strategy is to give me 2 points on the line. I should be able to specify your line. Or you give me 1 point on the line and the angle that the line makes with the positive x direction. Yes? If you give me those two pieces of information, again I can specify your line. Is that understandable? So have this geometry in mind. You see, this is geometry again, but we want to make it analytic. So it means that we want to make some numbers and equations. But before that, let us understand what is the mean, or how can I specify? For example, if I these are simple cases that you can immediately tell me the answer. So I will take this 1 and 2, for example. Let us consider this point is 2, and I draw a perpendicular line to the x-axis, okay? This is a straight line. I want to ask you, write an equation. An equation means in algebra. In geometry, we do not have equations, yes? I want you to write an equation for me that somehow can represent this line. Yes? What do I mean by that? I mean that, let us look at the points on this line. Any point that you like. Is there any relation between x and y coordinates of the points lying on this line? If you can discover a relation for the points on this line, that relation is called an equation for the line. I want you to understand what is the meaning of an equation for a line. So an equation for a line means an algebraic equation so that the x and y coordinates of the points on the line satisfy that equation. This definition is extremely important. I want you to understand, not just memorize it. But let us take it simple. Can you tell me, if you look at all these points share one property, and what that property is? Yes, Rasmus?
X is equal to 2.
All these points, if I ask you, can you read the coordinates of this point? You would say that I can read the x coordinate easily. But the y coordinate depends how much is this one, which I don't know. But I am sure about the x coordinate, which is 2. If I take it to the other point, so what can you say about this point? You can say whatever this point is, I am sure about its x coordinate. Its x coordinate is equal to 2. But what is the y coordinate? I don't know. So hopefully you realize that every point on this line share this property that the x coordinate of that point is equal to 2. Is that understandable? So we say that x equals to 2. If you don't see the picture and I ask you what is this is an equality in algebra. X equals to 2 is an algebraic equation, yes? But this equation, by having this in mind, can represent this line as a geometrical object. So x equals to 2 is an equation of this straight line. Yes, what does it mean? It means that, be careful about this point. It means that if you pick a point on the line, it satisfies this algebraic equation. Yes? And on the other hand, if you have a point that satisfies this condition, it definitely lies on the line. Yes? Is that clear? So I can say that x equals to 2 is a good equation which represents this line. And I do not say the equation, I just say an equation. Why is that? This is an equation for this straight line. For example, I write 2x minus 4 equals to 0. Is this equation identical to this equation? Are these two equations identical? No, identical. Identical means that exactly the same. They are not identical. But are they equivalent? Yes. Appreciate these words. So they are not identical because you see the difference between the form of the function. Here 0 appears. You don't have any zeros there. So they are not identical. But this equation also represents that one. Why is that? Because any point that, so this means if you solve that, it means x is equal to 2x is equal to 4, x is equal to 2. So if you tell me this equation also represents this line, I actually agree with you. Because 2x minus 4 is also an equation which represents this line. Why? Because every point on that line that satisfies this condition, every point that satisfies this condition lies on the line, and the other way around. Every point on the line satisfies this equation. So this is an equation for this line. This is also an equation for that line. So you can write infinitely many equations, all of them representing one single line. So preferably, we use with the simpler one. So this is an equation for that line. That is also an equation for that line. Is that understandable? Yes or no? Okay, for example, let me take it a horizontal line this time. So for example, let me take this one. It's a horizontal line, but let me assume that this point is minus 1. So how can I represent this line algebraically? Geometrically, I represent it. I just drew it for you. This is the only way that I can do in geometry. Take my ruler and draw the line. But if I want to present it algebraically, I have to write an equation so that it represents the property of all the points on the line. So what is that, Tim? Y equals to negative 1, yes? Because it doesn't matter which point you choose on the line, you can immediately read the y coordinates of all these points. So if I ask you what is this point, you say that I don't know the x coordinate. It depends how far is it from the origin. But I know something, the y coordinate is minus 1. I can say the same thing here, the y coordinate is minus 1. I can say the same thing here, the y coordinate is minus 1. Yes? So I can say that this equation, for this I can write y equals to minus 1 is a good equation. Or any equation which is algebraically equivalent to this equation. For example, I can multiply it by 5, I can multiply it by 7, whatever. Those are also equations having this, presenting this line. Is that understandable or not? Yes or no? Of course, the question becomes a little bit harder if I have neither this situation nor that situation. Horizontal lines are easy to write the equation for. Vertical lines are also easy to write an equation for. But let us consider the most general case. How can I write an equation for an inclined line? Neither vertical nor horizontal. Okay, so let us do it here. Okay, this I really want you to pay attention. I can write the formula for you only, but that is not good because I want you to understand these concepts. Okay, so here, what I want to do is this. I consider a point and I give you, let me be more specific, okay? So let me make it, for the time being, 1, 2, and 3, and 4, and let me make it 1 and 2, okay? I give you this point, 4 and 2. And I ask you to give me an equation for the line that passes through this point and makes an angle 60 degrees with the x-axis. Okay, so I just want to draw it. So you see, if I ask you to draw a line that passes through A, you see all these lines are passing through A. I need to fine-tune it in a way. I don't know where it goes, so let me take these away. I want to find that one which actually makes a 60-degree angle with my x-axis. Okay, so let me take them away. I don't know where this will intersect actually eventually. So let me write this. Okay, this is A, 4 and 2, and then this will continue, okay? Now, I want you to find for me a way that I can write an equation for this line if this point is 4 and 2 and if this angle is 60 degrees. So, what I want you to understand, this is a well-defined question. Yes? How many lines are there that passes through A and makes an angle 60 with the x-axis? How many lines are there? Yes? Exactly one. Exactly one. If that is not exactly one, that is an ill-defined question. That's an ill question. Because I am saying that write an equation for the line that passes through A and makes an angle 60 degrees with x. I want you to understand there is only one unique line with that property. First of all, is that understandable or not? There are no more than one. And there is exactly one. I want to find the equation for that one. Okay? So how should I do that? To answer this question, first you need to tell me what do I mean by finding an equation. Can you describe this question for me? I am asking you, find an equation, algebraic equation, that represents this line that you see on the board. Just give comments on this. What is the meaning of my question? Because this you need to know. What Babak is asking for. Babak is asking for giving me an equation. Okay, what? Equation of what? Yes, Rasmus?
Some equation involving x and y, for example, like x plus y is equal to 0.
Yes.
But of course, be something else for this particular line.
Okay, so the first part I really agree, but the second part I didn't like it that much. Can you complete it? You want to find a relation.
A relation between x and y. Well, I mean, usually people write this out, or you want to find an equation line that is true for all points that lie on our particular line that we're
Exactly.
looking for.
So that sentence, let me complete it. I want you to understand. When I ask you to write an equation for this line, I mean find a relation between x and y coordinates of all the points on the line. Is that understandable? Meaning that if a point on that line is on that line, it satisfies that property, that relation, and on the other hand, if you have a point whose coordinates satisfy that relation, that point should be on the line. So let me see that this is extremely important. I am asking you to find a relation between the x and y coordinates of all the points on this line. If you can find that relation is called an equation for the line. First of all, is that understandable for everyone? So I want to find that relation. How can I find that relation? So let us try to understand how can I find that relation. Let me take a typical point. I don't know which point, but let me choose this point, for example. Okay, this point, let me call it B. This point has one x coordinate, let me call it x, and it has one y coordinate, let me call it y. Yes? I want to find the relation between x and y. I don't know what is x, I don't know what is y. I just chose a typical point on this line. I called it B. I say that let us consider the x coordinate to be x, the y coordinate to be y, and use the geometrical property of the shape that you have, which is the straight line, and connect x and y together. If I can connect x and y together, that connection, that relation is called the equation for the line. Is that understandable? This I want you to really understand. When I ask you to write an equation for the line, what do I mean? I mean find a relation between the x and y coordinates of all the points lying on the line. How can I find that there? This is a different issue. How to find it is what we want to address right now. To understand what does it mean in the first place, I explained that. If you don't understand, please let me know. Okay, now we want to go to ask you, how do you think I can find that relation here? Do you find any method? You have to be a little bit creative, of course. You want to find a relation between x and y. Yes?
You can write y is equal to 1y is equal to how many x's? Like if you go up one on the y-axis, how many?
No, you are using your previous knowledge. Yes, that knowledge I don't buy it because I want you discover that knowledge. Yes? So how do you do that? You need to use geometry, trigonometry, whatever you have learned so far to establish a connection between x and y. Whatever you need is on the board, and if you need some numbers, I can give the numbers to you. If you don't have it in your memory. You need something in trigonometry, but whenever you need it, ask me, I will give you. I don't care about that one. What I care is the method. So Ali was right, but you need to do it right on the board. So with the information that I have on the board, you should be able to answer that question. Okay, I will draw a picture here for you, and then might be you understand what to do. From this point that I have given to you, I draw a horizontal line. Yes? And then from this point that I have taken myself, I draw a vertical line. Yes? Okay, and I ask you, what angle here is this? 60. So everyone you see, you know that. Okay. I want to establish a connection between x and y. Okay, can you find it now? Use trigonometry in this triangle. This triangle, by the way, is a right angle triangle, so you can use trigonometry here. So what should I write?
Cosine 60.
Cosine is not that good. If I want to write cosine, then I have to be involved with the distance of A and B. Yes? Do you remember the distance formula was the big square root sign? Yes? So the algebra becomes complicated. I'm not saying it is wrong. Yes? That's also one way. But we can do it easier. And that's exact, what, pardon? Tangent is better here. So do you realize what? Because if you say cosine of 60, cosine of 60, let me call this point M, that becomes AM divided by AB. Okay, AB, we learned how to write it. This becomes a square root of the difference between x squared plus the difference between y squared. And this is a little bit annoying, yes? If that is the only option, we have to keep it. But if we have a better option, we have to go for it. In this case, as Haya said, is that the tangent is working better. Yes?
Is the coordinates of B known?
Pardon?
Is the coordinates of B known, or is the problem to find the coordinates of B?
No, neither of them. The point is to establish a connection between the coordinates of B.
Okay, but
we will not be able to find x and y.
okay, so we can treat x and y as known, or
yes, exactly.
yeah, okay.
Yeah. So that's the point. So whenever you want to find an equation for the line from scratch, yes, this is the way that actually people have discovered that. They take a point there, and then what you realize is that you can write the tangent of 60 degrees is equal to. Okay, can you tell me what can I write in front? The opposite length, how much is that? How much is that?
AB equal to 9.
No, from B to M, so it is BM divided by AM. Yes? But BM, what can I write in this one, of course? What is BM? No, the difference between Y and 2. Yes, is that understandable? If I ask you what is the length from here to here, you would say it is 2. What is the length from here to here? It is Y. But I am interested in that part, so it becomes Y minus 2. And then if I ask you about AM, what can you say? AM is from here to here. So it becomes the x coordinate, which is from here to here, x minus 4. Yes? Is that understandable? Yes or no?
Yes.
Ali, did you understand?
Not completely.
Why not? So let me see. So do you agree that tangent 60 can be written as BM? This is M.
Yes.
BM
CM.
divided by AM. Yes?
Yes.
And if I ask you what is BM in this particular shape, BM is this length, yes? This length.
Yes.
And then from here to here is Y, because I called it Y myself. And from here to here is 2, because the Y coordinate is 2. So what is here is the difference between these two lengths, yes? Which is Y minus 2. Yes or no?
Yes.
And the same happens here. If I ask you what is from, oh sorry, might be you understand what you mean. That's my mistake. What is from here to here? It is X. What is from here to here? It is 4. So what is from here to here is X minus 4. Yeah, might be that was my mistake. Thank you. And then this is Y minus 2 divided by X minus 4. Is that understandable or not? Yes? Okay, I established the relation, finished. That is the equation of your line. I want you to understand, because some of you might want to explore something new, but I established the connection. So I would say that Y minus 2 is equal to tangent of 60 degrees, whatever this number is, I don't care, multiplied by X minus 2. This is the equation of my line.
X minus 4.
X minus 4, thank you. So this is an equation for my line. I want you to understand that technically you are done here. What I am supposed to find? I am supposed to find a relation between X and Y. A relation means an equality between X and Y. I have an equality between X and Y. So that is the equation of my line. Yes or no? Is that understandable? So which part you don't understand? Because I think that you are still thinking about your past knowledge from going to school on that. This is very strange. Yes, forget about it. Learn what I'm saying, we will rediscover all those things, okay? For the time being, what I'm supposed to do, I told you that you are supposed to find a relation, means equality, between X and Y. Which is of course true. You cannot just randomly write something between X and Y, but there is a logic behind that. We discovered that this relation should hold. And this is the equation of your line, okay? Of course, if I ask you, can you do it better in algebra? I would say yes, because tangent of 60, if you have it in mind, or if you have the table in front of you, it is a square root of 3. And then you multiply it inside, and then you move 2 to the other side, it becomes plus 2 is Y. Yes? And then if I ask you what is the equation, you can simplify it algebraically. Multiply it inside, square root of 3x, and then this becomes plus 2 minus 4 square root of 3. This is a little bit strange, but that is your equation. Finished. You cannot simplify it more than that. So that is an equation which represents this line. Yes? It means that if I take any point here, read the X and Y coordinates, put the X coordinate in this formula, I get exactly the Y coordinate for that formula, for that point. It doesn't matter which point I am using. Is that understandable or not?
Yes.
Yes or no? Yes or no?
Yes.
So you don't answer. Do you understand what is going on here? Yes? Okay. So let me try to motivate you again. So let me make it a little bit simpler for you. Okay, might be you should also have this. So let me ask you this question. I want you to use exactly this method. I am not saying that that would be part of the lesson. I will modify this later for you, but I want you to understand. Otherwise, you have to memorize. So if I give you this point, This I will call it 1 and 1. Yes, I will call it point 1 and 1. Now I ask you, write an equation for the line that passes through this point and make angle 45 degrees with the x-axis. So, I don't know, do you know it from your previous study? What is the equation for this line?
Isn't it y equals to x?
It's y equals to x. Yes, you know that. But forget about your previous knowledge. Let us rediscover it using this method. This method is completely generic. Yes? So, if I want to discover an equation for this line, and I give you this angle to be 45 degrees, then what you do, you take any point, random point, a typical point, not random, a typical point of my line, I call it x and y. Yes? What I want to do, I want to establish a correct relation between x and y. That relation is called an equation for my line. Okay, do it exactly as before. What I can do, I can draw a horizontal line from here, I can draw a vertical line from here. And if I ask you what this angle is, I hope that you agree that this is again 45 degrees. And then what I can do, I can write tangent of 45 degrees is equal to the opposite side, let me call it BM, divided by the adjacent side, that would be AM. Yes? And now tell me, what is BM? BM is from here to here. But from here to here is how much?
X minus.
No, y.
Y minus
From here to here is how much?
1.
1. So what is left for me is y minus 1. And then let me ask you again. So what is from here to here is x. What is from here to here is 1. So what is left for me? X minus 1. That's my equation. So it means that, but if you go to the table, what is tangent of 45?
1.
1. So tangent of 45 is 1. So this means that 1 is equal to y minus x, x minus 1. But if I have a fraction which is supposed to be equal to 1, it means that the numerator should be equal to the denominator. And then what happens here? I can simplify this, and that becomes your equation that you would be able to guess. Okay, but what I'm telling you is that this is the only way that we can discover the equation of lines. Yes, is that understandable? Yes or no?
Yes.
Okay. Now, let us do it completely generic. What does it mean? It means that I give you a point, I call it A, x node and y node, okay? And I give you this angle. Let me call this angle theta. And I ask you to find an equation for this line. Let us do it together. You help me to do this. I give you the point A. It means that I give you this number. I give you this number. I also give you this number, this angle. And I want you to find an equation for this line. Okay, what should I do? According to that method. So what should I do?
Draw a horizontal.
No, first of all, I have to take a typical point. Yes? I take a typical point, call it B, on the line of course, and the coordinates, I call them x and y, and try to establish a relation between x and y. This is the way that you need to think. Whenever you want to find an equation of a graph or a shape, you need to pick a typical point on the shape and establish a relation between x and y. This is the completely generic method. Okay, how should I do that? The trick is as before. I draw a horizontal line here, I draw a vertical line here. This becomes a right angle triangle. Okay? Now help me to write something. If this angle is theta, what this angle is? Theta again. So what can I write for tangent of theta? Is BM over what?
AM.
AM. But what can I write for BM?
Y minus y node.
Node divided by
X minus x.
x minus x node. Yes? And then what happens? I multiply everything by x minus x naught. So it becomes y minus y naught is equal to tangent of theta multiplied by x minus x naught. And this is your equation. So it is extremely important to understand that this is the end of the problem. If you think that you have to continue, I need to fix it somehow. This is your equation. Is that understandable? This is your equation. Because this is a relation between x and y. X and y, yes? And then these are given numbers. Okay, do you have any problems here? Do you understand what's going on? This is extremely important lesson because it will many things that you will learn in the future rely on understanding this method. And now this number has a name in mathematics. This is called the slope. Okay, this tangent of theta is called the slope of the line. So, if I ask you what is the slope of the line, it's extremely important. I don't know why, but it is absent in Swedish books, but this is extremely important to understand. If I ask you what is the slope of the line, you would tell me the tangent of the angle that my line makes with the positive x-axis is called the slope. That is the real definition of the slope. Okay? So a slope, the slope of a line is the tangent of the angle that the line makes with the positive x direction. And in the American or British books, they show it with M, but in your book it is denoted by letter K. Yes? And then, so we say that the equation is y minus v naught equals to kx minus x naught. And the British word for slope, if you do some A-levels, it is called gradient. I don't know, in English books you see, in British usually, not American ones. American ones they use a slope. But if you see gradient of a line, it means the same word as a slope. So they are the same words, okay? Okay. Now I want you to discover another formula for this slope. Okay? So usually a slope you have to work with tangent of an angle, and in Math 1C and 2C you are not that familiar with trigonometry. So we want to also find an alternative way to express the slope. But the slope is always defined to be the tangent of the angle between my line and the x-axis. Can I find an alternative way for the slope? Can you propose an alternative way for the slope? To calculate the slope? That is exactly what you know probably from your previous studies. Now we want to understand that they are exactly the same concepts. So how should I do that? Yes?
Y divided by x.
Not y divided by x.
What?
Not y divided by x. You mean which y and which x?
Okay.
So let me, because you need to be practical. So what I'm telling you.
Y-axis divided by x.
Okay. No, let me tell you something. I give you this line. Okay. And I ask you to find the slope of this line.
Yes.
For the time being, what do you need? for answering my question. You need a protractor. Take the protractor and measure this angle. Yes? And then whatever this angle is, calculate the tangent of that angle using your calculator, you get a number. That number is the slope. Forget about what you have learned in grade school. Forget about it for the time being. But what I told you right now is a slope is the tangent of the angle that my line makes with the positive x direction. So if I draw a line for you right now, forget about the previous information, and I ask you, give me the slope of this line, assuming that you don't know anything about the slope except the one that I told you, you need a protractor. Take the protractor, measure this angle, and calculate the tangent of that angle using your calculator, you get a number. That number is the slope of your line. Yes? Now, my question is that instead of giving you a protractor, I give you a ruler. And I ask you the same question. Think about this. These are important things, yes? I know what is coming next, not in this lesson, the other lesson. So these are important to understand in this way. So, I draw a line, give you a protractor, you calculate me the slope. Now, instead of giving you the protractor, I give you a ruler. And I ask you to find the slope. The same question, but with a different instrument. How do you do that? But you need to convince me that using the ruler, you are also calculating the same thing. This I want you to convince me. Okay, Aya?
You could draw a line from the top point of the line.
There is no top line, any point.
Any
Because this will continue forever.
Yeah, and vertical line, and then measure that line.
By my ruler, yes?
Yeah, and
this
then
would be L.
Yeah, and also the that length.
Yes?
And then those are the quantity, the measurements we
Yes.
need to
So by my ruler, I measure this, and I divide them. Yes? This is the way that I can do it with the ruler. Because if I divide L by H, this gives me the tangent of theta. Do you agree? Tangent of theta is nothing except L divided by H. So if I give you a protractor and a calculator, you can do it in this way. If I give you a ruler, you can do it in that way. Okay? That is possible. So by ruler, by protractor. Now I give you another type of question. This time, I give you 2 points on this one. I give you numbers. I give you the number here, for example, is x sub b and y sub b. I give you these 2 numbers. I give you another point, and I give you these numbers. Now using algebra, not measuring tools, how can I calculate? You see, in the previous 2 setups, I asked you how do you measure. Okay? But now I am asking you, I am giving you a pair of numbers for B, a pair of numbers for A, coordinates, and I ask you to calculate this slope. Then what can you do? If I ask you to calculate this slope,
Yeah.
so what is that? Yes?
If you just use the same formula like over there, like YB.
Exactly. So what I do a horizontal line and a vertical line. Yes? This angle is theta, this angle is also theta, but if I ask you what is this length, you can calculate, you don't need to measure. What is then answer? YB minus YA. And what is this answer? XB minus XA. And now I am supposed to calculate the slope. But according to the definition, slope is tangent of theta, and tangent of theta is the opposite side, which is YB minus YA divided by XB minus XA. So this is probably the formula that you remember from your previous studies, not the tangent of theta. But I want you to learn tangent of theta is also very, very important. So if I give you 2 points on the line, you can immediately put those numbers into this formula and get your K value. Is that understandable? Yes or no? Okay. Okay, so let me give you two examples. They are extremely important. Very simple, but very important examples. You need to have them in your mind all the time. Okay, I would ask you, write an equation for the straight line that passes through the point, let me say A, minus 1 and 2, whose slope is minus 3. So this sentence you need to remember. You want to write an equation for the straight line. I give you two pieces of information. I give you 1 point on the line, and I directly give you the slope. You don't need to calculate anything. Okay? So what should I do? This formula I really want you to memorize, even though this is in the formula sheet, but I want you to memorize that. And there is the name that the book call it, it's called 1 point formula. Yes, I want you to memorize that. So let us understand this. X node and Y node are the coordinates for 1 point on the line. Which point we don't know and we don't care. And K is the slope, that's it. So whenever I give you a point and I give you the slope directly, you don't have any problems writing the equation, yes? So what is the equation? I need to write Y minus, by reading this question, can you tell me what is Y node in this problem?
2.
It's 2. Equals to what is K in this problem? Minus 3. X minus what is X node in this problem? Minus 1. So it becomes minus 1. That's it. And then what you get is Y minus 2 is equal to minus 3. Minus 1 is plus 1. And then I move these 2 to the other side. So it becomes minus 3x minus 3. I move 2 to the other side. It becomes 2. And then finally I get Y equals to minus 3x minus 1. If you write this for me, I agree with that. If you move everything to the right and write this for me, I also agree with that. If you write 3x plus y and move 1 to the other side, I also agree with that. So you can write it in a lot of different ways. But this is the standard way. To write y with coefficient 1 and everything in terms of x there. Why is that? Because that's a function. When I write a function, do you remember? I write f of x, the y value equals to something in terms of x. Because of function way of writing, I prefer to write y alone on the left-hand side. But it doesn't matter. If you write it like that, that's okay. If you write it like that, that's okay. If you multiply it by 5, that's okay. If you divide it by 10, that's okay. Okay? But we use this one, is probably better. So you see, this is a very, very simple problem. I hope that you understand. So you see, I could write the formula for you and say that, okay, follow that. But I want you to discover these things yourself, to understand it once for all. Is that clear? Okay. Another typical problem that I want you to know is write an equation. Let me change it for you here. So let me clean these. And I ask you to solve this equation, of course, this problem. You also probably know what to do with that. These two problems are very important. Let me put a star, not because they are hard, because this is essential for other parts. So example. Okay, so let me write this. Write an equation for the straight line. By the way, here, when I say line, I mean the straight line. Let me write it, of course, here. Straight line that passes through the points let me write A with coordinates -1 and -3 and B with coordinates 5 and -5. So you see here, I gave you 1 point and the slope, and that is 1 point formula. So I took this one immediately and wrote my equation. This is important to understand. Another type, if you remember in the beginning, you told me that if I give you 2 points, that is enough. Now this is giving me 2 points. So how should I solve this problem now? Yes?
Well, I mean, the x in this case, I guess, is the slope. Well, I'm like writing an equation for this.
Yes?
So, I guess b, like anyway, it's -5.
No, you don't need to concern about the details. Just tell me what to do. I will do it for you.
The y of b.
So you should say it like this. You should say, for example, use this formula to find the slope. Yes? Now that you have the slope and you have a point, you can use this formula and solve the problem. Yes? So that is the method. So that's exactly correct. So the first thing that I do is this. I write k is equal to y of b minus y of a divided by x of b minus x of a. This formula is also given in the formula sheet, but I want you to remember it. It is not hard to memorize this. So then I will substitute the numbers. What is a sub y of b is -5. Don't get confused with minus signs. Minus y of a. There is a minus in the formula. There is a minus in the y coordinate. And then I go here. X of b is 5 minus x of a. A minus in the formula, a minus in the coordinate. And I simplify that. So it becomes -5 plus 3 divided by 5 plus 1. And then it becomes -2, 6. Simplify that is -1/3. So the slope of this line is -1/3. Yes? Okay, now that I have the slope, I can solve the problem like the previous problem. But then you have two alternatives. You can choose A as your point and solve the problem, or you can choose B as your point and solve the problem. What do you think will happen? If that is mathematics, the calculations should be consistent, yes? So it shouldn't matter if I use A and a slope to write an equation, or if I use B and the slope and write the equation. Let us confirm that is really independent of my choice. So you take one of these points, and let me keep the 1-point formula in front of your eyes for the time being. You can choose point A and solve your problem, or you can choose B and solve your problems. Let me choose A. So let me choose A and K and put it here. So can you tell me what should I put instead of y naught here? Can you tell me? I want to make sure that you understand how to use the formula. So what I'm supposed to put instead of y naught here?
-3.
-3. The y coordinate of the point that I have chosen. So it is -3 equals to, what is k? K is -1/3, yes? And what is x naught? X naught is -1 here. So it becomes -. Let us be patient and simplify that. So this becomes y plus 3. This becomes -1/3. X minus -1 is x plus 1. I told you that this is enough, but I think it's better to move everything and make y alone. So then it becomes y equals to, I multiply this -3 here. and then I move 3 to the other side, it becomes negative 3. And then let me simplify this. These calculations should be very easy for you. Yes? So what is the answer in your head? Can you tell me? You see, you are still very reliant on the calculator. You should be able to do these things quickly. Yes?
Is it positive?
Not positive.
Or
Minus, minus. I'm not multiplying, I'm subtracting.
yeah, but or
Yes?
Minus 4/3.
Minus?
No.
No?
maybe
Oh.
minus 10 thirds?
Yes, minus 10 over 3. Yes? So let me do the calculation here if you're a little bit not sure about what to do. So you need to write 3 in a way that the denominator becomes 3 because I want to take the common denominator, yes? How should I write that? I should write it minus 9 over 3, yes? Minus 1 over 3, minus 9 over 3 is minus 10 over 3. That's all. That is the answer to this. Yes.
So in this case, like the x and y in this case is a random point on the line, on the same line. Well,
No, they are not random. It means, let me tell you again. It means that if you take any point on that line that this is representing, read the coordinates and take them out and put them in this equation, this becomes true. Is that understandable?
Yeah, but like this for this specific line, but like you could write a different equation for the exact same line.
Yes, yes.
With
But that equation should be algebraically equivalent to this. Don't think. So what is your question exactly?
If you use b in this case, this would be the same. This would be equivalent.
Equivalent, not necessarily the same, but in this case it becomes the same. I want to check. Yes, you are right. There is no guarantee that, because that is why, you see, I am always asking this is by the way wrong, an equation. And yes, an equation. I cannot write the equation, because there are infinitely many equations representing the same line. If I have one equation, I multiply it by any number, that is still the same line, even though the equation has changed, yes? Okay, but let me confirm that it doesn't matter if you start with b. Okay, now help me to do the same thing. You have the formula in front of your eyes, let me just do it for you. So then it becomes, I am choosing point B this time. So it becomes y minus, y node in this problem becomes how much? Minus 5. And already you see this is different from here. The final answer matters, not the intermediate steps. Yes? So equals to, what is the k value? Is minus 1 over 3, x minus. What is x node in this problem? X node is the x coordinate of the point chosen, which is 5. And then I will start simplifying this. So it becomes y plus 5 is minus 1 over 3 times x plus 5 over 3 by multiplication. Then I move 5 to the other side. Yes? And now you calculate this again in your head. Can you do that?
18 over.
No, be careful.
It's minus 10.
Minus 10. Let us calculate. Make sure that everything is fine. What can I write for 15?
15.
What can I write for 5? I can write 15 over 3. Now it becomes 5 minus 15 over 3, which is minus 10 over 3. So this number is nothing except minus 10 over 3. And then you can compare the results. Okay, so you see the intermediate steps are different from the intermediate steps here, but the final answers are the same. And that is exactly what we expect. If we solve with one point, I get one equation. With another point, I get totally different equation. That would be discrepancy in mathematics. The mathematics is very sensitive to that. If you find one contradiction, all the mathematics will collapse. Okay. If you want to get rid of mathematics, try to find a contradiction there. So then you don't need to study mathematics anymore. Yes. Any questions? Is that clear?
So this is the simplest equation for this line possible.
Simplicity is a little bit subjective thing.
Okay, well,
So I don't know if, for example, myself, I don't like fractions. I prefer to multiply by 3. For me, might be this is more simpler. I don't know. So simplicity is a subjective matter, yes. But I usually go up to here because I told you I want to make y alone. So then I would say that the function f of x equals to minus a third x minus 10 over 3 is a function whose graph is a straight line. So that is why, because of function connection, I prefer to continue up to the point that y is alone. Yes? So do you see that this defines a function? Yes? I can ask you to draw the graph of the function. It means exactly the same thing. It means find all the points x and y so that these numbers satisfy the equation of the function. And that's exactly the straight line. Yes? Is that understandable? Okay. So these two examples I really want you to learn. So there are two formulas of importance for you. So the formulas that are important are these. One formula is y minus y node is equal to k x minus x node, and this is called the 1-point formula. And the other one is the k value. I can calculate the k value if you give me 2 points on the line. How should I do that? I subtract the y coordinates and then divide them by the corresponding x coordinates. By the way, it is very important. It doesn't matter which one you write first. But if you write y1 first and then y2, you have to respect the same order in the denominator. It doesn't matter, you can write y2 first, but then you have to write x2 first. Yes? And I don't know, are you familiar with this notation? The change in one value in mathematics is denoted by delta. And this, I would say this is delta y. It means the change in y values divided by the change in x values. So that is a shorthand notation for the same thing. So if you see this triangle, a small triangle of y, it means the change in y value. This is read the change in x values. That is also sometimes you see in the books. Yes? So that is the formula for that one. But I can write another one here, which we learned today. Probably you were not familiar with that. What was the definition of the slope in the first place? The tangent of theta. But if I ask you what theta is, you would say theta is the angle that the line makes with the positive, and this is important, x direction, x-axis. The positive direction of the x-axis. So this is the summary of what we have learned so far. So you need to know all of these things by heart. I really want you to memorize that. It is not hard at all. Okay, let me ask you something. We have some problems with the slope. Do you know when? Let us test your intuition. If you have a horizontal line, what do you expect about the slope of a horizontal line intuitively? Yes? If you have a horizontal line, what is a good number for representing the slope intuitively? And let us see, do they match, the calculation and the intuition match or no? if you have a horizontal line. If I ask you what is the slope of this horizontal line, what is a good number to say?
0.
Yeah, it is 0. Okay, is that understandable from calculational point of view, from two perspectives? Let us consider the angle perspective first. If this is the x direction, so let us take this line to be the x direction, and then this is a horizontal line. How can I calculate the slope of the line using the angle interpretation? If I have a horizontal line, what is the angle between my line and the x-axis?
0.
0. Two lines are parallel, so the angle is 0. Yes? And then, instead of theta, I have to put 0 degrees. And take your calculator and calculate tangent of 0 degrees. You will get 0. So that is understandable from angle point of view. Yes?
Could you write it as 180 degrees?
Yeah.
As a straight line?
No. That is the definition, yes? So, that's a good question. You can also, of course, even if you write that, tangent of 180 is also 0. So it doesn't matter if you write 0 or 180, both of them, the tangents are 0. Okay, but the other point is that, how can this formula tells you that the k value is 0? If I have a horizontal line, I take 2 points here, yes?
Y is 0. Oh wait, no, Y is the same.
Yes, the y coordinates are the same. So it means that when I calculate the difference, the numerator becomes 0 and the fraction becomes 0 because the numerator is 0. So you see, from angle point of view and from this point of view, they are actually completely according to our intuitions. Yes?
So vertical line is...
Yes, that's my point. Now I want to ask you the same question. What is the slope of a vertical line?
Undefined.
It's undefined. Again, using two perspectives. You can use this, if you don't believe, what is the angle in the vertical line? What is the angle when I have a vertical line? The angle with the positive x direction? 90. Take your calculator and calculate tangent of 90. You immediately get an error or an undefined. So it means that a slope of vertical lines are not defined. Or you can use this formula. But if I have a vertical line, what will happen? If I take 2 points, the x-coordinates are the same. If the x-coordinates are the same, the denominator vanishes. And then I will have a big problem. A fraction whose denominator is 0 is not defined. So remember from now on that if you have a horizontal line, the slope is 0. If you have a vertical line, the slope is undefined. And then I have two types of inclined lines. One inclined line is in this direction. One inclined line is in this direction. Okay? If I ask you what is the slope, you have to calculate. But I don't ask you the slope. I ask you, do you think the slope here is positive or negative?
Positive.
What about this one?
Negative.
Negative. Why is that? Because if I take these 2 points, when I go to the right, the y values are also increasing. So it means that if x2 and y2 are the final point, and x1 and y1 are for the initial point, y2 is larger than y1, x2 is also larger than x1, so this combination becomes positive. Yes? Is that understandable? So if I give you these 2 points, x1 and y1, and here x2 and y2. If I calculate k value, it becomes y2 minus y1, x2 minus x1. But because this one is higher, y2 is larger than y1. Yes? x2 is also larger than x1 because it is on the right hand side. So the numerator is positive, the denominator is positive, so when I divide it becomes positive. But what about this one? If this is x1 and y1, and this is x2 and y2. Now tell me, what is y2 minus y1 in this case? Positive or negative?
Negative.
Yes, because y2 is lower than y1, So y2 minus y1 is negative. But x2 is larger than x1. So the numerator is negative, the denominator is positive, so it becomes negative. So remember, that's also good to remember it. So you draw a horizontal line, k is 0. You draw a vertical line, k is not defined, undefined. You draw something like this, k is positive.
Nice.
You draw something like this. Oh, sorry. This is k negative. And then this one, k is positive. So I would recommend you to have this in mind. Horizontal, k is 0. Vertical, k is not defined. A slope in this direction is positive. A slope in this direction is negative. Okay. I think it's a good point to stop here. The things that I started with, you really don't need to know for the exam, but it is extremely important if you want to understand where these things are coming from. It's important to understand these things. We will continue tomorrow. Thank you. Any questions? Yes? No?